Hello and welcome. This is Matthew, and today we are going to install the IND file, or you'll see it written as IND $file utility on our MVS 3.8 system. And this utility is critical because it allows us to transfer files to and from our MVS 3.8 emulated mainframe using the file transfer capability in some 3270 terminal emulators, such as the X3270 client, the C3270 client that I've been using on Linux, as well as the Windows terminal clients like Tom Brennan's Vista client. So this IND file capability is included in modern versions of MVS, OS 390 and ZOS, but somebody has put together a free version that we can install on our very old MVS 3.8. And among other places, we can grab a copy of that from CBT Tape.org. The CBT Tape is a collection of, it's up to about 1,000 files now, various utilities, scripts, other tips and tricks for the MVS line of operating systems. It has mostly moved on to really focus on the current version of the operating system, ZOS, but there are some utilities that still work in the old MVS, and there's an archive of CBT Tape version 249, which contains a snapshot of what was on the CBT tape at a much earlier point in history, where the majority of these files will be relevant to MVS 3.8 and then some of the versions of MVS before OS 390 came around, is my understanding. But in any case, the IND file utility we need is still included in the current CBT version. So under downloads, I'm just going to click on CBT, and I'll go ahead and find IND $file. And you can see right here, file 607 is a free IND file version from Mike Rayborn. So it's a link to a zip file. So I'm going to copy that link and then back over in the terminal session that we've become used to in all the videos. Let me switch over to my shell, and I will just download that zip file. And if I unzip that, we get this file 607.xmi. So this is a transmit format file. And again, this is something that we see in newer versions of MVS, like OS 390 and ZOS, where TSO has a command to transmit a data set, and it will package it up in this transmit format. And so this is a fixed block, 80 byte record length file that is a sequential file. So it's able to package up a partitioned data set or any other data set that doesn't have a fixed block 80 record length format, and it packages it up into the sequential file that is consisting of 80 byte fixed block records. Now, if we had ZOS, we could just upload this to our mainframe and use the TSO receive command to turn this flat file back into a partitioned data set that has whatever the contents of this file are. However, we don't have the receive command in TSO. The good news is we have the RECV370 program, and that's already installed on our system because it comes as part of that sysc volume, that system compiler pack that we integrated into our build of MVS when we were following Jay Mosley's instructions. So before we work with this file, let's take a look at RECV370. So I'm going to switch over to my VTAM session here, and let's log on to our mainframe. I'll start up the review front end, and let's use our dataset browser, and let's look at that sysc collection that we have on our system. Now, if I page down with F8, I believe there's a data set in here. let's see, what am I looking for? There it is. sysc.receive370.asm. So it looks like that is the package it comes in. Now, if we browse this, there's some instructions here on how to install it. We can see that we actually have the source code for the utility, along with a couple of other things. And those details are all in some of the README and install members here. But we are interested in the receive member. So if we look at this $RECV member, let's just browse that file. We have some documentation here. So it looks like RECV370 was written by James Morrison. This is a name you'll see quite a bit as you look at a lot of the what we have available to us for our MVS 3.8 system. And it looks like it's released under an open source license, so that's great. And we have the source code there if we want to look at it. As we scroll through here, it looks like the important bits here are, okay, we want to run RECV370. So to build the JCL to run RECV370, we need the following DD names in our JCL. And they're all documented here in this file if you ever forget them. So RECV log is where the output messages are going to go. So we would normally just send that to sysout. Looks like receive debug is optional. So if we have some debugging options, we can provide this. I don't know what debugging options are available, so I always leave this off since it's optional. And then XMIT in, this is important. This is the input data set, so that transmit file that we want to receive, and that's required. That makes sense. sysprint is where IEB copy output messages are going to go. So internally, the RECV370 program uses IEB copy to put it looks like partitioned data sets back together. So if we are restoring a partitioned data set, which most of the time when we're working with these transmit files, this is what we're going to be doing. We need to provide sysprint. So again, we'll just usually send that to sysout, no problem. sysut1 is the work data set for IEB copy. Not needed for sequential transmits, required for partitioned transmits. So again, we're almost always going to be receiving transmit files that are partitioned data sets. So we'll usually need to provide a sysut1. That's a work data set, so we can just provide it a temporary data set. Okay, we'll remember that. And then sysut2, output data set, sequential or partitioned. So sysut2 is where we will specify the data set, and usually we'll be creating a new data set in our JCL for the output of the receive operation. So that input file, XMIT in, is going to be reconstituted, if you like, into sysut2. And then sysin, again, if we're using IEB copy behind the scenes because we are restoring a partitioned data set, that's the DSORG physical organized, I believe is what PO stands for. At least that's how I remember it. It's organized because it's a partitioned data set, as opposed to PS, which is a physical sequential data set. In any case, sysin is going to be needed when we are restoring the partition data sets. And it tells us this just needs to be a dummy data set. So we'll go ahead and create a sysin DD, which is tied to dummy. Okay. So really, that's all we need to know. We just need to write some JCL that runs the RECV370 program. And we need to provide these DDs that are in this documentation. And that will read whatever we provide on XMIT in, and it will put the output at sysut2. Now, the RECV370 utility itself is up here in the sysc.linklib. So this is where all of the executables on that sysc pack are. So if we go down several pages, we should see Lots of compilers, lots of utilities here. Let's see. Yep, should be around here somewhere. Yeah, so there it is. So RECV370 is in our sysc.linklib dataset. So I think we know everything we need to know to do this. So the first question is, if I switch back over to the shell, I have my transmit file here just on my Linux file system, on my Linux server that's running Hercules. We've unzipped our CBT 607 file, so I'm just going to delete that to keep things clean here. This file 607.xmi is the transmit file we need to load. So since it's on our file system here, I'm going to switch over to Hercules. And on our emulated mainframe hardware, we have a spare card reader at address 1C. So we can use that card reader to load in that transmit file. Remember, those transmit files are fixed block with logical record lengths of 80 bytes. So they're perfect to send in through an emulated card reader. So I'm going to use the devinit command in Hercules. I'm on the Hercules console now. So devinit the device 01C, and I'm going to put in my card reader the deck of cards represented by downloads file 607.xmi. And I need to include the EBCDIC tag here so that Hercules doesn't try to treat this as if it were a text file of JCL and do the translation from ASCII to EBCDIC. We just want it to read this in as essentially a binary raw file. And so we do that by including EBCDIC on this devinit command. So now this file, this transmit file, is sitting as if it were a deck of punched cards in card reader 01C. So let's go back to TSO, our RFE editor here, and let's write the JCL to receive that file with RECV370. So I'm going to go to my mwilson.control data set, and I'm going to edit a new member that doesn't exist. We'll just call it receive. And we'll start writing our JCL. So I'll call it mwilson R. Make a quick job class here. Let's make sure our output is going to our held output queue. Again, on this system, when I was customizing the JES2 parameters during those installation videos, I set it up so that we don't need a programmer name or account number. If you didn't do that, your system may need more parameters here in the job card, but if you followed along with my customizations, this will work just fine. And then really, we just need one step in this job. We'll call it RECV370. The program we're going to run is the RECV370 command. I'm not sure what our default region size is or how much it needs, but I'll just give it 2 megs here. That should be plenty. Now, this RECV370 program, remember, it is in our sysc.linklib library, and that is not part of our system-wide concatenation of link libs. So we're able to provide a step lib DD, and that applies to this step, this exec, and we can tell it where we want to look for the executable that we're running. So we know that's in sysc.linklib, so I'll set that as the step lib. And then I took notes, so you don't have to. The DDs we need here, according to the RECV370 documentation, are receive log. So this will be the log output, and we'll just send that to sysout. We need sysprint. We're going to send that to sysout. I think that was the IEB copy output. We need sysin for IEB copy, and that, the README said, is just a dummy data set. We need a temporary work data set called sysut1, and we'll just pop that on any direct access volume. We can give it quite a bit of space because it's not going to stick around. So we'll just do 10 cylinders and 10 alternate, 10 for the alternate extent size. We're not naming it or anything, so it won't stick around or get catalog after the fact. And then the important one, transmit in. Well, I guess they're all important because they're required, but the one we'll recognize as being the most obvious. Transmit in. This is going to be our card reader. So this is how we can read that XMI file, the transmit file, from our card reader. So the unit is going to be O1C for that card reader device that we put the file in Hercules. And we will explicitly tell it here that we have a fixed block record format, a record length of 80, and the block size, because we're just reading one card at a time in a card reader, will be 80. So that's our input on the card reader. And then sysut2 is our output. So where do we want to put this? I'm going to create a new data set called mwilson. Let's say cbt.file. Was it 167? That sounds about right. Let me switch back to my shell. I'm sorry, 607. So I'll just call it cbt.file 607. And this is going to be a new data set. We will catalog it when things are all said and done. I'm not particularly concerned with the volume that this goes on. We'll just say unit sysda and not worry about a volume serial number. Let's continue this line. We'll need to allocate some space for it. If we look, I'm going to switch back to the shell again. Let's look at this file, file 607. It's 254K, roughly. So we don't need a ton of space. You can do the math, but I'm just going to wing it and give it, say, 10 tracks, 5 for the additional extent length. And because we're restoring a partition data set, we need to provide some directory blocks in this data set. So I'll give it 10 directory blocks. And again, it's a new data set, so we're going to make sure that it gets created the way we want. So this is going to be a fixed block data set with a a record length of 80. Again, I'll continue this. We'll say block size 5600, which is a multiple of 80. And dsorg equals physical organized, so that we end up with a partitioned data set. So I think that looks good to me. Let's just confirm really quick. Job RECV370. We're going to be running that from sysd.linklib. Receive log, sysprint, sysin, sysut1. That should be fine for a bunch of temporary space. So XMIT in is our card reader, fixed block 8080. And then we're creating a new data set, mwilson CBT file 607. It's new. We'll catalog it. We'll put it on direct access storage. We will allocate 10 tracks for it with 10 directory blocks. And the record format will be fixed block with a record length of 80 and block size 5600 into a partition data set. All right. So with luck, that should work. So let's go ahead and submit this job. That's submitted. I'm going to use my favorite RFE feature, which is like a feature in ISPF. So I'm going to start a new RFE session, and we can directly jump in the menu structure to utilities and the out list so we can see our job output. So you can see this little tiny 2 here. We're in kind of session 2 or window 2 of RFE now. And sure enough, there's our mwilson receive job. So let's select that job. And we got a condition code of 0. That's always a good sign. That usually means it worked. And if I just page down here, we can see the output from RECV370, and it's listing. In fact, this is now, it used IEB copy to restore all of these into a partition data set. And you can see we restored a number of members into this data set. So that's great. That worked. So that's how we use RECV370. We write JCL. We include all of the DDs that are listed as required in the RECV370 documentation. And we're able to take a transmit file and receive it to a partition data set, or sometimes a sequential data set that just has different blocking, different characteristics. So let's exit out of that. I'll go ahead and purge this job's output because it was successful. We won't need to refer to that anymore. I am going to hit F9 to switch back to session 1 in RFE here. F3 to exit, F3 to exit, F3 to exit. And now if I do a DS list in M. Wilson again, you can see we have a new data set. So M. Wilson's CBT file 607 was created on volume work 01. So let's browse that data set. And this is what we got from that transmit file on the CBT tape, file 607. So there's some information here. There's a README here that you can look at that talks about kind of what's here and the history of this project, some of the terminal emulators they've tested it with. And if we look at this $file command, load lib, at first I thought, oh, okay, great. This is the executable. I just need to copy this into my maybe sys2.linklib and or command lib maybe, and I'll have the INDFILE command. And so I kept trying to do that, and I was getting incorrect blocking errors, and it just wasn't working. So with a little more effort and kind of bouncing ideas off of some of the guys in the Moshix mainframe Discord channel, it occurred to me that this is in fact another transmit file. And so I'm just going to look at this file. I'm going to browse this file. And of course, it's just a bunch of gobbledygook, just kind of raw, binary data. But the key here is if you see this INMR01, that's a clue to you that this is a transmit file. And before I knew that, when I was looking at this, it wasn't really making sense because this doesn't look like an executable. If you browse actual executables over in sys2 command lib or sys1 command lib, they don't look like this. And like I was seeing this P390 name, which I know is the name of an older either ADCD OS390 system or the physical P390 card, sort of mini mainframe that you could get a while ago. And it had the name of some other executable programs, the actual code page translation programs, in addition to INDFILE. So anyway, long story short, this is another transmit file. And what I found with these CBT tape files is they tend to package up either another transmit file or a raw tape image along with some additional information that is put together by the curators of the CBT tape, kind of like the date and a change log and maybe some README information and an identifier for the file and where it came from. But the actual program or utility or library that you're trying to install is oftentimes packaged up in a second level under that outside transmit wrapper of the CBT tape format. So I don't know if that made sense to you, but what we're going to have to do is receive this INDFILE member of file 607, and this contains the programs we actually need to install into our system. Now, if we look at this JCL member, most of what we need to do that is already written for us. So let's edit the JCL member, and you can see this is loading the tape. So normally INDFILE was distributed on tape, and the process to restore it would be receiving it from the, I guess, first file on tape. But we don't have that tape. We have a transmit file that represents what would have been on that tape that we could restore from tape with IEB copy. But we don't want to use IEB copy. We need to use RECV370 to receive this transmit file. And it looks like the files are the actual IND FILE command, the code page command, these code page translations. So what we're going to do, we're not going to use this JCL that was written to load from tape. We're just going to go back and use our receive JCL, and we're going to point it to the member in this file, in this data set. So let's see what that looks like. Let's exit out of this, go back into here, and edit our receive job. And so this time, XMIT in is no longer going to be our card reader. It is going to be our existing file. Let's see if this paste works. Nope, I'll just do this manually. It was let's see, wilson.cbt.file 607, and the member name was IND_file. And this is an existing file, so disposition is shared. And then instead of restoring to a new data set, we are just going to restore this directly into sys2.commandlib. And that is, again, an existing data set, so we can do disposition shared. And we'll delete those lines. So if this was the first time we were doing this, if I didn't know what was in this IND file, transmit file, right? If I had no idea what I was about to receive, I probably wouldn't do this directly into my sys2 command lib. I would, and you know what? In fact, we're not going to do it this way. We're going to make a new data set. And so that new data set is going to be, we'll call it mwilson. We'll just call it IND file. And let's, we'll do disposition equals new catalog. The, let's see, unit, we can do sysda. I didn't really plan ahead for this. I didn't need to delete those lines. And then we will make the DCB of this. We'll just make it match sys2.commandlib because that should be correct for compiled executable programs. And then space, again, we shouldn't need a ton of space. I'll do my usual 10, 5, 10. So does that look like it'll work? We're going to go ahead and receive this IND file bundle, this transmit file, into mwilson.INDFILE. Okay. If there are any mistakes, you've probably already seen them, but I don't see any, so we'll submit this and we'll let the logs tell us if there were problems. Job submitted. I'll hit F9 to switch back over to my session 2, which is still the job list. And I'll just hit enter here to refresh that. And let's look at the results of this new job. Okay, condition code 0, that's what we want to see. If I scroll to the bottom, it looks like we have received some members. Perfect. So let's purge that job, F9 to switch back over. And now I'll go back in here and you can see in mwilson.INDFILE, sure enough, we have what we need. And now if I look at INDFILE, it's no longer a receive file. It's now a some kind of compiled executable, I guess, along with a couple of other files. And overall, that whole thing is just an unformatted data set, which is what we'd expect for these compiled binaries. So now the last step is to go ahead and install that into our sys2 command lib so that if we just run the INDFILE command from the TSO prompt, it will actually execute that utility. So to do that, we can go in and use that JCL that has already been written for us. So let's look in that restored file 607 again and edit the JCL. I'm going to rename it mwilson, maybe L for load. This is all good. Message class I want to change to X. Now this is going to use IUB copy to simply copy the members we want from that data set we restored into sys2.commandlib. So it's already set up for the way we've built the system using Jay Mosley's commands or installation guide, where all of our add-on commands we're installing into sys2 commandlib instead of messing with the sys1 commandlib that is kind of shipped with the operating system and managed by IBM's processes using SMP. So the other thing we need to change here is we're not loading from a tape. We're actually loading from that data set that we restored. So we can say DSN is mwilson.end$file. Disposition is shared because it already exists. We'll just go ahead and delete all of those extra lines we needed to identify the tape. And then disk is sys2 commandlib. That is where we want them to go. And then the commands to IUB copy is that we're copying from the DD called tape to the DD called disk. So those two are defined right here. We can still call it tape, even though it's not actually a tape anymore. And then we're going to copy the members end file. We're going to replace end file if it already exists in sys2 commandlib. And we're going to copy code page 1047, and code page 37. This allows end file to do ASCII to EBCDIC translations when we're transmitting and receiving, or I should say maybe uploading and downloading ASCII files, text files with our 3270 client. Now this db stop and db start stuff is if we've installed a dynamic library manager in our MVS system. We have not, so I'm going to delete those lines. We don't have that db start and db stop procedure on our system, so we don't need those. But otherwise, I think this looks good now. Again, we're copying from this data set we restored to our sys2 command lib partition data set. So let's save that. Let's submit that and see what happens. Flip over to the output list with F9. Select that. Perfect. Our condition code was 0. I'm just going to scroll to the bottom quickly, and you can see that those members have been successfully copied. So purge that. And at this point, I'm just going to hit F3 to exit out of a bunch of this. If we look at sys2 commandlib now, and we browse that, you can see, sure enough, there's those new code page programs. And down here is the end file program. So all the files are in place. So what we saw here was, I'm just going to look at mwilson one more time. Let's look at our JCL, our receive JCL. We can run that RECV370 program, which we need to add a step lib of sysc.linklib so the system knows where to find it. We can run that with these data definitions, and we provide our input file and our output data set, and that will receive these transmit format files and reconstitute any partition data set members into the new data set that we create in sysut2. And again, all these were documented back in the sysc, and then it was sysc, I think, receive370.asm. Let's see. Yep, there it is. Let's browse that. In this $receive member in sysc receive370 ASM, the documentation in here of the receive370 DD names is how we learned what we need to put in our JCL to use this receive370 utility. So does it work? Does our new IND file capability actually work? So using IND file to send and receive from the terminal emulator is probably a video unto itself, but let's go to our shell really quickly here. And I'm just going to make a file in my home directory, maybe call it test file. This is a test, hello world, hello mainframers. Okay, so that file is in my home directory here. Now, if I go over and I'm at just the TSO prompt, I should be able to use the file transfer capability of the the C3270. My tongue's tied there. I should be able to use the file transfer capability of my C3270 terminal to send a file up to my mainframe. And it will use that IND file program behind the scenes to do that transfer. So the way you do that from C3270, if your terminal has enough lines and you have mouse integration reporting in your terminal emulator, you'll get a menu bar up top here from C3270. It'll just be a text menu bar. And you can actually click in there. I think there's a file menu and then a transfer option. But I don't have enough lines here, so I can use the escape sequence in C3270, which is control right square bracket. Right, so I'm gonna hold down control and then hit that right square bracket command, the close square bracket. So control square bracket, and I'm now at the C3270 prompt. So I'm now giving commands to my terminal emulator. And one of those commands is transfer. And this will now walk me through prompts to use IND file to send or receive a file to my mainframe. So yes, I want to continue. In this case, I'm going to send a file. I want to move that text file in my home directory up to the mainframe. Name of the source file is home mWilson. What did I call it? I think I called it test file. So that's the source file name. The destination file name. Now remember, it's running the IND file command through TSO. So the TSO prefix applies and the TSO dataset name rules apply. What that means is if I want to provide an absolute dataset name, I have to surround it in single quotes. So I can say mWilson.testFile in single quotes, and it will end up at that dataset name. I'll hit enter there. Host type. So IND file is available for TSO and VM. I've never used it for Kix, so I don't know how that works in a Kix environment. But in this case, we're sending to the TSO environment. And because I created this as a text file on my Linux workstation, I'm going to use the ASCII transfer mode. If I were sending a transmit file up, for example, now that I've installed IND file, if I download another file from that CBT tape archive that's a transmit file, I don't need to read it in through the card reader, right? I no longer need access to the Hercules console. That'd be like having physical access to the mainframe hardware in the data center to be able to put that tape deck in or put that stack of cards in and get it all ready. I can now send those transmit files up to my mainframe remotely from my 3270 terminal emulator. And I would send those transmit files up as binary. But in this case, it's a text file. We'll do ASCII. Carriage return handling. Do I want to remove those? Yeah, usually you want to remove them, so I'm going to remove them. Remap character set, sure, that sounds good. Why not? Now, destination file record format. So this is how IND file is going to put together the allocation statement for the data set on disk. So in this case, I'm going to do fixed. Logical record length for text file will usually be 80. Block size, I'll just stick with 5600. Probably not optimal for some of the volumes I'm sending to, but it is legal, so we'll stick with that. File allocation type. So again, here's where we're going to allocate space. This is a small file, so I'm just going to give it 1 track at one secondary space. And the buffer size, I just leave it a default of 4096. This is just used for the transfer. This doesn't affect the dataset allocation on the DASD. Okay, so let's hit enter there. And that looks good. Let's send it. So this is taking too long. This should be done by now. Yeah, transfer did not start. So what happened? It's something about, I've noticed, I don't know if this is a bug or if this is something I'm doing wrong, but it doesn't like something about how I'm allocating the data sets. So you know what I'm going to do? Actually, let's resume the session. We can see the command it's running here. I don't actually want to run that. Can I? Looks like it's kind of stuck here. Well, okay, so I'm going to hit Control bracket again. If I do reset, does that do anything? Yeah, I've kind of gotten stuck like this before. So this is not how I intended the video to go, but this is a good exercise. So my 3270 TSO session seems a bit broken now. So I'm going to switch to my MVS console. And I want to kill my TSO session. So I need to remember how to do that. I think I do cancel. Is it cancel user equal M Wilson? No. Okay, so what do I do in this situation? I go back to my web browser and I search for MVS console commands. And one of these pages here is going to be, let's see, this one from, this was the original turnkey project, I think. So one of these is going to be, I was so close. It's not C comma U equals user ID. It's just cancel space U equals user ID. Okay, so back to our MVS console. Cancel space U equals M Wilson. Okay, so that'll append my TSO session. Switch back over, log back on. Let's see, get my password right. Now I'm going to look in RFE just to see, did that data set get created at all? It did. Okay, I'm going to delete that. And let's try this again, and I'm just going to do something a little bit differently. So Control, close square bracket. We'll do the transfer. Yes, I want to continue. I want to send. That's the source file. That's the destination file. It's TSO. We'll do ASCII, remove carriage returns, remap character set. I'm just going to do default for the record format. And it's not letting me just default back to, because it's forcing me to use my old, okay, we'll do 80. 5600 is fine. Okay, I'm going to do default here. Default file allocation. And then that's fine. Confirm. Okay, so that worked basically instantly. So I'm not sure if there's a bug when I'm giving it file allocation size and tracks, or if I gave it a bad allocation. But it looks like in this case, just using default file allocation type worked. So I'll hit enter to resume my session. We're back in TSO now. May as well start up the review front end again. Now, if I look at that test file, here's our sequential file. It looks like we got a logical record length of 255, which isn't quite what we were looking for, but whatever. So let's look at this file. And sure enough, I have a file. This is a test. Hello world. Hello mainframers. So that did work, despite the little problem I had there that I don't quite understand, but we worked around it. We saw how to kill our TSO session when it wasn't behaving. And then we just logged back in and tried something a little bit different, and it worked. So that is INDFILE. Again, the magic key, and you have to be at a TSO prompt. So that could be this TSO command entry panel in RFE, or it could be if you just quit all the way out of RFE and you're just at the TSO prompt. Control right square bracket in your C3270 emulator will get you to the C3270 prompt, where you can then run transfer and send and receive with IND file. Okay, I'll hit enter just to get back without doing anything. But I hope that was interesting, hopefully helpful. I think after we've done our work setting up our MVS system, certainly installing IND file, I consider a pretty critical step to get a nice usable mainframe system, because that really allows us to easily and quickly start transferring files back and forth from our terminal emulator wherever we're running it, instead of having to load everything in through emulated hardware devices on the Hercules console. And we also looked at how to use RECV370, which was more the point of this video, which is when you have those transmit files, how do you restore them or reconstitute them into data sets on your mainframe? And the answer to that is with the RECV370 program. And you can go back in the video and see the JCL to do that. So thanks for watching. If you enjoyed this video, I always appreciate the thumbs up and the subscribe. I'll continue to put out some more MVS 3.8 content here, along with other things that strike my fancy on the channel. So thanks again for watching, and we will see you next time.